Hey guys, I hope you're doing well. Let's take a look at number 1080, 200, wow, 13, 2, 1, 2, 1, 3, intersection of three sorted arrays. We're given three integers, 1, 2, 3, sorted in strictly increasing. Well, this is a super hint for us, right? Okay, we turn a sorted array only the integers that appears all in three arrays. So 1, 1, 1. Okay, we collect 1. And then 2, 2, 3. No. The next one is 5, 5, 5. Yeah. While we can do this brutally, like we check this element and do the search, check if it is in this array and in this array. And yeah, if we do brute force, of course, because it's ascending, we could use binary search to search for it, right? So for each element in array 1, I'll suggest that if suppose all n integers, we could loop through the first array, and for each element we can do search in both arrays, right? So that leads us to O n times the binary search would be log n and 2, right? So we get the n log n. Well, obviously this is not, we haven't used these conditions. It's strictly sorted, and you see when we are checking the result, we say we can analyze some characteristics from the real example. The first one, 1, all are 1, so we push it. Next one is 2, 2, 3. So the numbers in array 3 could not be under 2, right? Under 3, right? Because it's bigger than 3. So we can safely skip the double twos in array 1 and array 2. Go to next one. Next one is 3, 5, 3, right? Well, we do the same. We can ignore the inanimals in the array 1 and array 3. So we can actually loop through all the elements. I mean, always check the heads of each array. If they are the same, we push it to the final result. And then if not, there must be two smaller numbers, right? So we just shift the top elements in the smaller array, and do this over and over again until some of them are empty. Well, check the head until one is dead, and pop the smaller one. Well, technically it's not pop, but it's shift. Well, if you do this, we need to what? A complexity. You see, each element will be checked only once for the worst case, right? Well, so it's what leads us to linear time. Okay, let's do that. So we first create the final result array, and then we return it. And while array has some, while there is some, all of them has elements. Well, pick the head, okay? So it's head 1 equals a r1 0. If they are the same, it means we could use this one, right? So we pushed it. We push it. And then all three heads could be shifted. So for the other case, we will shift the smaller ones, right? So how could we do that? The only thing is that the only one we could avoid shifting is the one bigger, right? Like for 1 1 2, we will shift 2. We shift this ones, or if it's 1 2 2, we will shift these ones. So how can we do this? For this first one, it must be some for 2. We say it must be all bigger than the next one or bigger than some of them, right? So if it is not this case, we can pop it. Or we say for element is smaller or smaller or equal to all the next to the other numbers, then it could be popped, right? For 1, it's smaller or equal to 1, smaller than 2, it could be popped. But for this 2, it's smaller than 2, but it's bigger than 1. If it is smaller equal to and then equal to this one, then it must be handled in this case, right? All three are equal. So we could say if head 1 is smaller than head 2, 1, 3, we would need to shift 1, right? Now we do this recursively. 2, 3. Now we shift 2. 3, 1, 3, 2, 3. Yeah, so we are done. The time would be linear. Space, we're not using extra. We only use this array to keep track of the result. So it's worst is linear. Okay. Yeah, let's run the code. Cool, we're accepted. And yeah, so this is actually a simple one. For a multiple arrays problem, no matter what we require to do, the usual improvement for the brute force solution would be use 3 pointers to traverse through all the elements together and pop if it is needed. And yeah, hope it helps. See you next time. Bye bye.